box. That's all good. Anyone know any machine learning paradigms? Maybe the paradigms is kind of confused word. Just take one example. Supervised learning is one machine learning paradigm. Do you have any other? Do you know any other paradigms? No? Oh, that's great. Yeah, reinforced learning. Actually, I hope someone to say something like supervised learning, unsupervised learning, because they are always together. So yeah, in reinforced learning, that's is a very complex topic. I will give some introduction on that. But before that, supervised learning and unsupervised learning are the main topics, main learning paradigms for this course, for this unit. So anyone know what's the difference between the supervised learning and unsupervised learning? Easy question for you, maybe? You can just unmute yourself. Yes, please.
Yeah, I think it's supervised learning if we know the pattern, we know the answer, what we are looking for, and we try to learn the model to get his head or get his mind around what we're trying to achieve. And it has like two parts, like a training, another one for testing and validation. Unsupervised, we have the data, but we don't know what we are after. Actually, we'll let him go through it.
Yeah.
To me, supervised is like we have the label, like more of us, like we know, yeah, all the data has been labeled.
Yeah, that's great. Label is very good word. We always use a word as labeled, but in more formalized way, we always say that we have X, we have Y. We know as sorry, what's your name? Ammar.
Ammar, yeah, Ammar.
Ammar, sorry. Yeah, as Ammar said, we know the objective. And Margaret says it's label, right? So that is why we want to mapping the data to the objective Y. So, but for the unsupervised learning, we don't know nothing. We just want the model to explore the data. But what's our objective? It's like, actually, technically it's not like that. We don't know anything. We know something is. Normally, we know there exist some patterns in that. So we want to say this pattern. So sometimes we use the word latent variable. You maybe can see this latent variable as Y as a label, but we don't know what's that. We can't concretize that. This is a common use case to use supervised learning. We want to analyze the patterns. We want to explore the latent variables. But of course, sometimes we don't, Amma is right. Sometimes we don't know anything. We don't know if there exists patterns here. We just want to try unsupervised learning, try to cluster this data. If there exists patterns here, we will find if there does not exist pattern, so nothing there. And I think there's someone wait for me. Wait a minute, I will check. Yeah, I don't think I have permission to let him in. Okay, so okay, let it go. Just continued for. Yes, just let me continue. Okay, so yeah, data not labeled for unsupervised learning. Yeah, all the answers are very, very correct. So yeah, go back to the reinforcement learning, right? If you go to, let me share the first reading material for you. Actually, in this reading material, I will give you some idea of reinforced learning. Firstly, of course, I will give you idea of supervised and unsupervised learning. All of you are correct, all good. But for reinforced learning, can you tell me where the where does the data come from in reinforcement learning? In supervised and unsupervised learning, we have a file. This file we have data in each row. Maybe we have one example. Second row we have another example. But how about reinforcement learning? Any idea for that?
Every time the model runs and it learns something.
Oh, but how the model gets the data when the model runs?
It has a set of rules that it has to follow, and then it learns how to adapt and get better at it.
Yeah, that's how generally reinforced learning will learn. They will get how to do better things. But but where it can get the data to learn, it has to have a data to say, okay, this data is bad data, this data is a good data. So when we say this data is good data, when we say this data is bad data, so in that case, we can, learn better thing, as you see.
We
Is
have
it
to put it
like-
in initially.
Oh, sorry, maybe Simone, you can. Sorry.
You have to put some data in initially for it to start learning from.
Yeah, but where this initial data come from?
From the
It's still-
programmer.
Yeah, oh, that's good guess. Yeah, thank you for that. Actually, it's not the case. The data is always from the environment, how we learn as a humans. Think about how we learn as a humans, as a child. If you have a children, let's think about how your children learn things. It doesn't have you don't give the, some data, let him or her to read each data one line by another line. You just put it into the real world. It will interact with the environment. Maybe it will pick up some dangerous things. It may be hurt her or hurt him. Then he will note, oh, it's bad action, it's bad things for me to do. So in this case, the data is like, what's the X? What's the input? The input is like, oh, what's the state of this environment? How we can get this input? The children, the humans have eyes. We have eyes. We have we have the we have sorry. Yeah, where our eyes we can see something. So that's our input. We can have some state transformed by our eyes. Then we see this input. Then what's the output? Output is like, oh, what should I do now? Now I have this input. I know the state of the world. Maybe there is some interesting thing on the ground. I want to pick it up. Okay, that's the output. That's the output of a human. That's also the output of a reinforcement model, reinforcement learning model. Then if this action, this output will, if this output leading to the bad outcome, then you will learn something, right? If you get bad outcome, you will be published by some hurt of some. You get blood. It's bad things. If you do something good, maybe your parents will reward you some food, reward you some, take you to the playground. You will feel happy. You will do it again. So that's how reinforcement learning will work. Let's compare these two, not two paradigms. Let's compare the unsupervised learning, supervised learning paradigm, and the reinforcement learning paradigm. The key difference, there are two key differences. One key difference is in supervised learning and unsupervised learning is static. The data is static, but in reinforced learning is all dynamic learning. The input is dynamic, the output is dynamic. The input is a world. The world is changing, right? It's not static. and the output is action. The action, the action is also actually it's not deterministic, right? Because think about the supervised learning. You have one example. If you want to classify a sentence reviewed on Amazon into positive or negative, one review must be positive or negative. But for in reinforcement learning, sorry, you have you can give different actions. All actions you give is valid, so it's dynamic. So output is also dynamic. And another difference is dependent. Think about supervised learning. Most of supervised learning and unsupervised learning. If you have a first example, you have a second example. You have a prediction of first example, then you let model to predict for the second example. It won't affect the prediction of the second example, right? The first review say, oh, this product is very bad. Then the second review maybe say, oh, this product is very good or bad, but nevertheless, it doesn't depend on the first example. But in reinforced learning, if you are in the stage 1, then you perform action for stage 1, it will lead you to stage 2. Then you will perform action according to stage 2, right? The stage 2 is dependent on your stage 1 and the action you perform on the stage 1. So that's the two difference. Yeah, I don't want to go too much details in reinforcement learning, but if you are interested in that, you can see this blog post. It's also this dependent and independent issues also lead to a very famous problems in reinforcement learning called exploration and exploitation. Anyone know that? It's a very interesting topics and lifelong topics in reinforcement learning. Yeah. Oh, by the way, there is another things very important in supervised learning and unsupervised learning, because that is what you will learn in this unit. So I want to ask you this question. Anyone know there is a very important assumption under most of supervised learning and unsupervised learning called RID assumption? It's kind of statistics concept. Because reinforced learning, as I said before, is dependent, but supervised, unsupervised learning, mostly they are not dependent, they are independent. The data is independent with each other. So the RID stands for independent, identically distributed. Anyone know that? Yeah, this is very important things I want to bring it up. Yep.
I think that your data is not biased, so you assume your data is distributed across the spectrum. You take it from different angle, because if it's biased, you get wrong answer. This couple of acronyms for that. Okay, it's the top of my head.
Yeah, that's really great. Sorry, what's your name again? Amar?
Amar. Add another A, make it AMAR. Amar.
Oh, yeah. Hopefully now I can remember. Sorry, Amar. Okay. Yeah, Amar is totally correct. Yeah, that's the things. I want to give you. I might use the word bias, but bias maybe confuse some of you. I will give you a concrete example. It's like we still the Amazon review. Okay, we want to train the model. Now we have Amazon review. We have Amazon have a lot of products to sell, right? So the buyers will give the reviews for these products. And we have Netflix. I think most of you have used Netflix, right, to watch movies. So for this movie, they also have movie reviews. So if we train our models on these movie reviews, maybe there exists a movie called Avengers. I think you know Avengers, right? Don't tell me you don't know that. I will be sad. Yeah, Avengers. Avengers is kind of fantastic movie for most of people. Sorry if it's not fantastic for you. So the model will learn, there correlates the Avengers to the positive review. So next time when you run this model on the Amazon review, the Amazon review, maybe one review will be something like, oh, it's making me Avenger because it's a bad product. So this is a negative review, but the model will predict it as positive. Why? Because it's trained on movie reviews. It saw a lot of positive reviews with the word Avengers. So as now go back to Ahmad said before, bias, it means bias take the meaning of the, you can think it in this way. Why Ahmad say is biased? Because you train it on the Netflix reviews, but the Netflix review, this data set is biased because it's biased to one kind of characteristics rather than to see the whole picture. So that's why we call it bias. It's really good word for that. Thank you, Ahmad. Any question for that? Let me see if we have some comment. Yeah, like data, you talk about the reinforcement learning. Yeah, that's data from sensors. That's yes, that's good. That's good. Data not able. Yeah, besides clustering, what else can supervised learning be used for? Oh, who said this question? This question is interesting. Baron. Hopefully I'm pronounced correctly. Yeah. Yeah, besides clustering, we use I just take one example in my domain. There is various purposes for using unsupervised learning. My domain is language intelligence model. It's like ChatGPT models. What we want to learn is what we want to learn from the language is like we want to learn the I don't want to say embeddings. We want to learn the representations of the language. But you know, the language, maybe there are a lot of words, a lot of vocabulary, a large size of vocabulary, a lot of language, Chinese, English, all those things. So if we want to learn some abstract knowledge, abstract semantics from them, we can just, we can use unsupervised learning. One kind of unsupervised learning called self-supervised learning. You don't have label, so you use unsupervised learning to learn some representation. This representation is just like a matrix and vector, some scalar values, a lot of scalar values together. It's maybe meaningless for people, but it's meaningful for models. That's how ChatGPT works internally. And another use case is like you want to just as I said before, it can extract it can represent data into matrix. So you can take control of the size of the matrix. If you think the original data is too big, you want it to be small. So you make this resulting matrix very small. So you do something called dimensionality reduction. That's the thing we'll talk about in later units. So it minimizes the loss function. I'm not sure. We need to minimize loss function for almost all the supervised learning and unsupervised learning. Teaching, yeah, great. So teaching a robot how to work in simulating its chest movement and involves understanding about how to move on a lot of attempts. Yeah, that's true.